Okay, the next section says something about odd, even, or neither. Here's x squared. I did it on a piece of paper. Now what even means is, well, they say it's symmetric about the y-axis. So here's the y-axis. You imagine grabbing a hold of the y-axis and spinning it like that. You spin it over, spin it. If you spin it 180 degrees, you would get exactly the same picture because it's like there's a mirror running right up and down on the y-axis and the two halves match. So if you spin it, you're going to get exactly the same picture. Okay, so that was x squared. And they call that symmetric about the y-axis. And then ultimately say that's even because it's symmetric about the y-axis. All right, now here's x cubed. Okay. Now if I take this and I take a dart or something and I jam it straight into the board, okay, so it's not going up and down the axes, it's just going straight in, and I spin, I'm now spinning around the origin. And if I spin 180 degrees around the origin, I get exactly the same picture. Okay, so that's symmetric about the origin. And that counts as being odd. Okay, well, everything you did, if someone said, was this odd, is this even, you could put it into your calculator. And then you could decide based on, oh, does that look like I can pick it up by the y-axis and spin it around? Or does that mean I could jam a dart right into the middle and spin it that way? You could do that. That would tell you whether or not things were odd or even. But what you could also do is you could look at the powers. These words, odd and even, they seem to match up with the powers. Okay, so 5x to the 3. That's going to be odd. And it's not the 5, 6x to the 3 would also be odd. I'm not looking at the numbers, I'm looking at the powers. X to the 3 is odd no matter what number's in front of it, even if it's like negative 2x to the 3. That doesn't make a difference. It's just the 2 to the 3 that's causing that. Okay, same thing with squared. So 7x squared would be even. Or 8x to the 4th. It doesn't have to be 2's and 3's. Any even power, you're going to call it even. Any odd power, you're going to call it odd. And, let's see, x to the 1 power, we don't usually write x to the 1, we usually just write x. It's to the 1 power, so that's going to count as odd. Plain old numbers, okay, like if it just said 5 out here, plus 5 or something. If it says just 5, that's even because it's really like 5x to the 0. No one ever writes x to the 0. But so plain old x's count as odd. Plain old numbers count as even. Now if we have x squared plus 8x, and we have to say odd, even, or neither, you're not allowed to just say, oh, well, this is even and that's odd. You have to take the whole thing as a picture. That's even and that's odd, but that doesn't match. Okay, if it's a mix like that, it's going to come out as a neither. If I graph this on my calculator, I won't be able to pick it up by the y-axis and spin it. I won't be able to jab a dart into it and spin it. Neither one of those is going to work. And it's called neither because half of it was odd and half of it was even. It doesn't match. It's a neither. X to the 5th minus 6x cubed plus 1. Odd and odd. Plain old number, but wait, plain old numbers count as even, so I've just said odd, odd, and even. It doesn't match all the way across, so I'm going to write neither. X squared plus 2x to the 6. Okay, that counts as even. X to the 2, x to the 6. That counts as even. I just said even and even. Never said odd. It does all match. That's even. X squared minus 5 over x minus 3x to the 8. Okay, x, that's just plain old x. All right. Okay, so it's got a division in the middle of it. It doesn't actually matter. You can still just look at all four things I can see here and see whether it works out even. Plain old numbers, so that's even. Plain old x, so that's odd. X to the 8, so that's even. Even, odd, even. Okay, that's a neither.